One of the best black mats to support the Younger Dryas impact hypothesis is around the San Pedro River in Arizona. So I went down there to check it out, but it was purposely buried under rocks so that it couldn't be seen or studied. So I had to look for the black mat elsewhere. In neighboring ravines, I found it hiding underneath a thin layer of sand. Once I revealed these outcrops, a chaotic story came into view. A story of strong currents and huge amounts of deposition. So let me explain. You see these layers of rocks? These are called graded beds, and they indicate currents during deposition. Since it takes a decent current to introduce the rocks, then as the current slows, fine-grained sediments settle on top, and the process repeats. Therefore, we can see the pulsation of currents during the time of this rapid deposition. The black mat is thick here and becomes stratified out downstream. This doesn't happen with calm deposition. Now, finding ash and crossbedding is a real treat for catastrophe proponents, because it shows how this gravel was deposited as it flowed over uneven surfaces. And it shows how the current undulated. These are both features of river deposition. Wavy layers of ash also show river deposition. Here's a fragment of charcoal I found. Thick layers of alternating gravel and sand indicate flood turbidites, like what is found around the Columbia River from the Ice Age floods. And some have proposed a link between these two events, as they occurred in the same time period. The ash is found sequenced across multiple vertical feet of strata. Within the same ravine, this distance can be traced to be as much as 20 vertical feet. Ash layers are found incredibly inconsistent here. So what makes the Murray Springs in the covered-up Leonard Mammoth kill site so special is that it's an incredibly thick layer of ash, and very fossil-rich, in mammoth, bison, tapir, and horse bones, as well as a few human artifacts. This means that the currents gathered the ash and bones together and deposited them there in the masses. And this is not a kill site. That is why there are graded beds here. And all the other features I talked about in the area. But none of this is unique to Arizona. The same features of flood deposition are found to be very impressive in South Dakota, Mexico, Chile, Alaska, Denmark. But the impact proxies must not be ignored. But they are dismissed because they are sequenced throughout multiple vertical feet of strata. But this is a feature of flood deposition, which is intertwined with this catastrophic event. This whole valley shows signs of river deposition, which means this whole valley was a river during this catastrophic event. The theory of this event is that around 12,000 years ago, Earth crossed paths with the torrid meteor stream that caused impacts all over the world. This is based upon the many impact proxies in sediments corresponding to this time period. The impacts created forest fires that destroyed habitat and burnt many megafauna remains. The ash of these forest fires make up the black mat and other thinner layers of ash in these areas. Impacts on ice sheets caused catastrophic melting that swept away and destroyed the Ice Age megafauna, leaving them in layers characteristic of flood deposition. This is also why the black mat and the impact proxies are stratified out throughout multiple feet of sediments. This shows flow pulses from a powerful flood catastrophe caused by rapid meltwater. Many of these locations are near where there once were ice sheets or ice-capped mountains. This explains the impressive meltwater flooding. But the two locations that make the least sense are in Arizona and the Channel Islands offshore of California, because the farthest extent of the Laurentide ice sheet at this time was 37 degrees north. This most generous estimate puts it nearly 400 miles away. But the Mogollon Rim is a huge watershed divide, and there aren't any mountains high enough to hold huge ice caps in this southern Arizona region. But nonetheless, this whole valley has 20 plus feet of flood deposition, with impact proxies and forest fire ash stratified throughout it. So let's keep studying it to see if there are any more clues to understanding this perplexing and catastrophic event. And yes, that's a fragment of a mammoth tusk I found near Murray Springs. We're going to do a real in-depth dive into this Arizona black mat. We're going to go through and we're going to look at some of these sites around the Sierra Vista area. And we're going to start off with the area around Murray Springs. Here you can see high up in this strata a nice layer of black mat that is above the graded beds. This is a really clean example of the black mat. Most places I haven't found it as continuous as in this spot. And then not too far from it, the black mat disappears and is replaced with a graded bed. This location looks pretty mundane, but when you zoom in, you can see that there are layers of gravel in between the layers of clay, and you can see its wavy pattern. In this spot, you can find a thin layer of black mat around this white mud that we keep finding. Here's a really good example of crossbedding, where you can see the wavy pattern in the strata. And there's the forest fire ash stratified all over, and there's a little piece of burnt wood. And that orange stuff is actually hematite, which is an iron compound. Again, we keep finding more of this hematite. This is definitely connected with the event, but I'm not exactly sure how. This is one of my favorite examples of that black mat ash in crossbedding, and then it's also got that hematite on it too. So a lot of the places around this Murray Springs area has a lot of iron, and it's really satisfying to reveal these outcrops with scraping them free. Yeah, this area's got a ton of gravel around that black mat ash. And then it's right next to that spot where it's got the thick layers of ash in the gravel and with the hematite all around it. I revealed a really nice section right here. Very beautiful. You got the graded bed above it, and then you've got the crossbedding below. Then you've got that black mat ash. You can just scrape it free, and the more you scrape it, sometimes the more black mat you find. This spot does a clear job of showing the currents. Look at all of these different layers of crossbedding. This is fantastic. And you can only imagine how much of the impact proxies are stratified throughout here. You know, the nano diamonds are probably all throughout here, and I'm sure there's some iridium anomalies here as well. Okay, this is in the same ravine, it's farther up, and now you can see a really thick graded bed on the lower layer, and there's the black mat ash in patches all around this area. You can even see the wavy pattern of this graded bed. And then as you look up, then you can see crossbedding, and you can also see the undulating path of this current. Here you can see that nice swooping undulation with black mat ash in it, and crossbedding all around it, and a graded bed above it. And if you keep looking up, you can find a big section of a graded bed. And this is not an even distribution, it's just a section, and that's from where the river cut across and deposited all of this rock. And then this is just right next to it, you can see a nice double section of the graded beds. There's my rock hammer for scale. And then you can see some black mat ash right there. And you can see how it's not very consistent. They just kind of pop up in patches. And then way up top on this outcrop, you've got another graded bed with black mat ash at the bottom layer of the graded bed. And then this is just right next to it. You can see the wavy pattern of the gravel, and this is crossbedding. And if you look at the brown and white mud layers, those are the same layers that we saw above the last graded beds. So this is over 20 feet higher from the last area I showed you. So those two graded beds, both with the black mat ash, are very different in vertical height. So this shows us that this whole event, which has this same black mat ash and probably has the same nano diamonds and iridium, was from a huge depositional event. So at Murray Springs, you cannot dig or remove anything because there are some real cool relics to find. And so I'll show you what I came across when I was walking down this ravine. I walked past it a few times, but when I saw this, I knew it was a fragment of a mammoth tusk. Super cool. Definitely a highlight of the ravine for sure. And if you look at it, it's not even deposited level, right? It's at an angle. And then if you go right next to it, you look at the clay that's right over next to it, you see all of the warping patterns of the clay. Turbulence deformed all of these clay layers. Okay, so back to the map. Where should we go next? Let's check out the Leonard Mammoth kill site. Air quotes on the kill site, by the way. Which doesn't explain the thickness of the black mat. It doesn't explain the nanodiamonds, the iridium, and the other impact proxies, shocked quartz. Okay, so this is that exact area where they found the mammoth, bison, tapir, horse bones. Based upon the other spots we've looked at, we've seen how the black mat kind of pops up in certain pockets. And all of the good pockets that were full of the black mat and the mammoth and the bison and the horses are covered up. Even though they covered it up, right next to it, I could see the graded beds, so I could get an idea of the deposition of this event. So this is a good example of the graded beds, where you can see the layers of rocks and how the current undulated as well. Okay, back to the map. We're going to go to a ravine that's in between the Leonard and the Hergis. And this was by far my favorite location. Really cool black mat here. Highly recommend this location. I'm not sure what the name of the ravine was. I couldn't find the river name, but it's super cool. You'll probably find it if you want to check it out. The black mat is most thick here, and as the current flowed downhill, the ash got sequenced out with sand layers in between it. This is about 2.5 vertical feet of layered ash. Now, scientists will date the black mat as accumulating over the course of 260 years, or in this case, 1,300 years. And when it gets sequenced out, they will interpret the layers as each individual and unrelated events, separated by hundreds, even thousands of years. But flash floods can deposit many feet of sediments in just a few hours. The level of debris proves the minimum for water height. So this is a big reason why scientists hate the Younger Dryas impact hypothesis, because it messes with their view of stratigraphy and shows how the percent error for carbon dating is much larger than they would like to admit. Yeah, definitely one of my best shots, and I cleaned this whole outcrop up. It didn't look like this when I got there. You could barely see the black mat, but I scraped it clean, and it was definitely worth it. And then this is just right next to it. This is probably 500 feet away. Really cool wavy pattern. And then here we've got a thick layer of black mat that's got a lot of gravel in it. And then right above it, thinner black mats, kind of wispy thin layers. And that's more just in the dirt. And I cleaned up this whole outcrop too. It didn't look this nice when I got there. Really cool. Another cool spot where you can see the different thicknesses of the ash. Never around here is there something that says calm deposition. And then I'm not sure what this was. I found a few of these yellowish balls. I thought it was sulfur, which would have been really cool. It didn't smell like sulfur and it didn't burn, so I don't know what that was. Again, really cool wavy layers of ash, very thin layers of wavy ash. So I don't think anyone should think each one of these little thin layers of wavy ash was from a different event. Revealing the outcrop here, I accidentally unveiled a little black mat lizard, but I rehabilitated him. I gave him a new habitat, so he'll be all right. He was really cold, though, and groggy when I woke him up. Yeah, so this is a great outcrop. And you can go to Sierra Vista and check it out. It's right between the Leonard Mammoth kill site and the Hargis. Okay, so now you can see the gravel in this black mat. So there's a strong correlation between graded beds and the black mat. Check out this outcrop. This is not just showing deposition, it's showing erosion within the layers. After deposition, the current came through and it carved through the deposition and then deposited the layers that's above it. And that's why we find this boundary. Now, when we look at the corner of this boundary, we see that it's full of beautiful crossbedding with gravel layers in it. So again, like when you find crossbedding, you're talking about river deposition. So not just rapid deposition, even erosion can be seen in this deposition. Very catastrophic stuff, nothing mundane about it. All right, since they've been trying to cover this stuff up, I'm going to look at it through a magnifying glass. This is 3 times. And it can just help us see the real fine strata. Okay, you can see the thicker layers, the thinner layers. And all of this actually has to do with the current speed. So the current in a river is never constant. It's always changing. Thin layers like this are made in beach sand, where several feet can be deposited by one storm during one high tide. When the current slows, it allows for very light ash to be deposited. So thicker layers of ash show longer periods of slower currents. And below it is a gravel layer from when the currents were flowing faster. Again, in this area, when we look closely, we can see how hematite was deposited throughout here. You can see the orangish tint that gives it away as being an iron compound. And then here also we find the brown mud and the white mud alternating in layers. So this is something we find throughout this whole San Pedro River Valley. The last spot we're going to check out is way down here by the Greenbush Draw. Most of this area was private land, so I couldn't really go down there and check it out. But with the drone, I was able to check out some outcrops, and I found some more graded beds. And this is way farther away from Murray Springs, so we're talking about a huge area of the same type of deposition. So we've got the graded beds here, and then above it, we've got layers of not ash, but actually topsoil. So we've got stratified out topsoil. And I also found some of this topsoil that was stratified out by Murray Springs as well. All right, that's the video on the San Pedro River Valley and the black mat layers around it. Hope you guys enjoyed it. Give it a thumbs up if you liked it, and subscribe if you haven't already. I really appreciate it, and you guys are what helped me to make more videos. So I appreciate all of you guys for watching the video.